Okay, sixth graders, we're going to talk about lesson 13.5. Yesterday we worked on graphing equations. Today we're going to talk about how those equations and how graphs are used to show what is happening. So we're going to talk about how to read graphs and interpret graphs. Okay? The first thing, whenever you're looking at a graph or a chart, you always want to look at the labels. You always want to look at the title. Copy these. Look at the labels. This is a graph of distance and time. Distance and time. Okay? We also need to look at the slope of the line. What does the slope of the line mean? What do you think slope of the line refers to? Any idea, anybody? How is the line changing? What is it doing as it goes from left to right? Caleb, it's going up and down. Sometimes it's going flat, it's straight. So, let's interpret this and read what that means. Since this is time, as time is moving, let's say that this is minutes. Okay? So in minutes, this is 1 minute, this is 5 minutes, this is 10 minutes. And let's say that since this is a car trip, this is distance from your house. Okay? Now, if this is distance, what is this slope going up represent?
Going further.
Going further, right. Going away from your house, right? And is the distance increasing as you go or decreasing?
It's both. Both.
Okay?
Both. Yes. Because it's like.
Wait, just in this section.
Yes. It's increasing.
It's increasing. So you're moving at a constant rate. You're driving down the street away from your house, right? Yep. Now, what is this part of the line? What would that mean? Is the distance increasing?
No. That means you stopped.
But is the time continuing?
Yes.
Yeah. What might this be?
Someone stopping to go to the bathroom.
Well,
then
yeah, if you're traveling from here to school over the course of 10 minutes, would you probably need to stop and go to the bathroom?
Yes. I got it. Because you need McDonald's.
Hopefully not.
Traffic.
Coffee.
What else could this be?
McDonald's.
A red light.
A red light. This could be a red light. Okay? What's it more likely to be, Gray? If you're stopped from 2 to 4 minutes. You're stopped for 2 minutes.
McDonald's.
Okay?
Traffic.
Traffic, red light, something like that, right? The point is that you're stopped, right? This represents the car stopping. Then from here it starts going again. Yep, and you're increasing away from your destination, or where you started from, the starting point. What would this refer to?
Detour.
Could be a detour, yeah. It could be a wrong turn. What does it mean? You're going back toward your house for some reason. Maybe you thought you
Forgot something.
forgot something, turn around, yeah. Oh, and then you get to a point, oh, I found them. So then you start going again, and
You're there.
another flat line.
That's good. Look at there. You're waiting to turn into the school parking lot.
Right, so what is this graph telling us?
They had to stop.
It's a story, isn't it? It's a story of what's happening. It's a story of what's going on. Please don't start talking when I'm talking. Let's take turns here. So the graph tells a story. How do you know what the parts of the line represent?
The labels.
The labels. distance and time, okay? Now, they're not always going to be distance and time. What if this had to do with speed and time? Okay, what if it was speed and time? Starting at 0, a very steep line would represent what?
Faster.
Accelerating faster, right? And then a flat line would represent what? No.
Cruise control.
Speed, not distance.
Stop.
Is this a, are we increasing speed?
No,
No.
staying at the
Are we,
same.
we're staying at the same speed, right?
Yeah.
What is this, what would a decrease represent? Slowing down.
Slow down.
Yep. What if it went all the way to 0?
Then you stop it.
That's a stop, right?
Yeah, the traffic light.
But the line doesn't stop, all right? Just that the car is stopped, the speed is stopped, right?
Yes.
What if it looked like this?
I don't know. You're going into a crash.
Then you don't stop.
Would be,
You don't.
well, that would be an immediate stop, wouldn't it? That would be going up, and then a crash would be immediately stopping and going to 0, right?
Maybe you're slowing down for a light.
Maybe it's just a slowdown, yeah. Yep. Yep. Which, if you were, class, if you were going down a hill, are you more likely to increase speed or decrease speed?
Increase.
Increase. So listen, this is something that you gotta pay attention to, okay? Listen, you're going down a hill, but the speed line is, especially let's say if you were biking, okay? If you're going down a hill, the speed would increase, and then if you're going up the hill, your speed would decrease. You see how the opposite parts of the line show what's happening. So if it's if you're going down a hill, you're going up in speed, and if you're going up a hill, you're going down in speed, right? So these graphs can be interpreted that way. Look at your worksheet that I handed out today.
You didn't have it out.
Didn't I hand it out?
No.
I thought I did.
Oh, we don't have a math worksheet.
Yes, we do.
No. We don't.
Do we have?
Oh, here it is.
Oh, yeah.
I mean,
Here, why didn't you go?
All right, pass these across.
Too many.
give me four.
I just need one. Give me two. Stand.
All right. So look at what it says. A graph can show the relationship between two different measures, speed and time, speed and distance. Those are two different measures. A graph relates time and distance. The closer a segment is, the closer a segment of the graph comes to being vertical, the faster the car is going, and so on. How can you tell which stop? How can you tell which stop took more time in the line?
Because the line was straight longer.
Yeah, if it's straight longer, this is a longer stop than this is, isn't it?
Yes.
Yeah. So a longer straight line would be a longer stop. You can write the answer in. Number 2, which section of the graph shows the greatest speed?
First one, the last one, because it goes straight up.
Yeah. Yep, because you are, well, wait. If
No.
it's speed and distance, wouldn't
Yeah.
the distance increasing faster,
Oh, okay. Never mind.
right?
Here.
Be the third one?
No, the second one. The steeper the line,
Oh, yes.
You did not.
The steeper the line would be the farther distance, right?
But, wait, I thought.
You're increasing distance faster. That means you're going faster. Describe where the graph shows the car moving forward.
The middle one?
Anytime the line is going up, or it's called a positive slope, would be moving forward, right? I guess the line going down could be the car moving backward, but it's more likely a turnaround or a detour, like we said before, right? And then describe how to draw a segment that shows a return trip with no stops.
Just one line.
One line, a negative slope, so it's going down to 0, back down to 0. Then, you can practice this on the back side. There are graphs both of time and distance, and time and speed.
You have to do the top.
Yes, do the top. Okay? Yep.